the ratio amount of heat required to rise the temperature of a body by 1 degree Celsius divided by amount of heat required to raise the temperature of same body by 1 Kelvin takes the value. When considering temperature difference, we know that 1 Celsius difference is equal to 1 Kelvin difference. Therefore, we can obtain same amount of heat energy for given two requirements, to increase 1 degree Celsius and to increase 1 Kelvin, because of there is a same temperature difference, same value for the difference of temperature in Celsius and Kelvin. We have to get only difference when comparing Kelvin value with Celsius value for a corresponding temperature. There is a difference, but when considering difference between two temperatures, difference of 1 Celsius is equal to difference of 1 Kelvin. Then required heat energy is same, therefore ratio should be 1. Then answer is 2. Which of the following curve best represents the variation of temperature T with the heat supplied due to the substance which undergoes a change of state at a given pressure? We know that when giving heat energy to a substance, we can consider it is as water or any other material. We can observe that there is an increasement of temperature. Then it will reach the temperature corresponding to phase change. It means liquid to gas or solid to liquid. At the corresponding temperature, we can observe that when giving heat energy, there is no change of temperature. But after the phase change, again we can observe that there is an increasement of temperature. The graph should be like this. Fourth one is the correct answer. In an experiment to find the specific latent heat L of ice using the method of mixture, the students dropped a large piece of wet ice without wiping out water on its surface into a calorimeter containing water at room temperature. During the experiment, he observed a layer of mist formed on the outer surface of the calorimeter. He can expect the lower value of L. L means latent heat. They have given 3 statements. They have to select correct statement. First statement, as the ice cube was wet. You know that when using mixing method, heat energy absorbed by water, it is type MS theta, should be equal to ml. ml means heat energy absorbed by ice when melting. This one is heat energy absorbed by ice. This one is heat energy emitted by water. This one is the normal relationship. But when mixing ice, there is a water mass. Ice cube is wet. Therefore, actual ice mass is a small value. He could obtain the mass reading in the experiment. because of mass reading is mass of ice and mass of water in wet surface of ice. Then mass reading is a higher value than the actual mass of ice, then L will be smaller than the actual value. Then statement A is correct. Statement B, as the ice piece takes a considerable time to melt. If there is a large time to melt, we know that there is an heat energy absorption. There is a heat energy absorption by the environment. Therefore, we have to add heat energy absorbed from the environment to the left hand side. But when calculating, we are using only this part. We are neglecting this heat energy. Therefore, L value will smaller than actual value. Then it also correct. Part C, due to the formation of mist. We know that if there is a formation of mist, a heat energy due to the environment by the mist, due to the calorimeter and water system by the mist. Again we have to add heat energy given by the mist. Then same thing, L value will be a small value than the actual value. Statement C also correct. Then all A, B, C are true. Answer is 5. Heat energy is supplied at the same rate to 100 grams of paraffin and 100 grams of water in two similar containers. The temperature of paraffin raise faster. This because the paraffin, we know that we can observe a faster temperature change if the heat capacity is smaller value. Then we can get paraffin has a small specific heat capacity. Answer should be 4. There is an error in answer. They have given has a small specific bar capacity, not bar capacity, it should be specific heat capacity. An immersion heater rated 150 watt is embedded in a large block of ice at 0 degrees. The specific latent heat of fusion of ice 3 into 10 to the power 5 joules per kilogram. How long does it take to melt 10 grams of ice? We can get that heat energy given by immersion heater for a T time is PT. P means power. Power means heat energy given per second. We have to multiply by time to get the heat energy given in T seconds. It should be equal to ml mass into latent heat of fusion. There is only a phase change because of ice is at 0 degrees. It is melting point of ice. Then we can substitute values. Power is given as 150 watt. We have to find time. Melted ice mass should be 10 grams. We have to convert it to kilograms. And they have given latent heat of fusion of ice 3 into 10 to the power 5. Then we can find the T value by using this equation. We can cancel out 3 zeros, 10 to the power 2. We can cancel out 1 zero. Then T should be 300 divided by 15. It is 20 seconds. Then we can get third one is the correct answer. we have to find the ratio between latent hot heat and specific heat capacity. Then we can get cooling rate at this phase should be equal to given value, it is given as 2, and we can get that there is a constant temperature for this time period. Therefore, we can write heat loss rate at this point is ms theta divided by t. It should be equal to, for this period, ml divided by t. We have obtained there is a constant heat loss rate for this period because of, according to Newton's cooling law, heat loss rate is depending only with excess temperature with room. Then we can get specific heat capacity into temperature. Cooling rate is given as 2. It should be equal to latent heat divided by time to fusion. Time to solidification is 10 minutes. Then we can find LOS value. It is 20. This one is the correct answer. Then for this question, there is a mixture of water. Then heat loss of this system, mass into specific heat capacity into 100 minus theta is the temperature difference. When getting temperature difference, we have to consider high temperature is this one and low temperature should be theta because of this system is cooling. It should be equal to heat gained by this system. Mass is not given, it is capital M, specific heat capacity. Now temperature difference is theta minus 30 because of theta is greater than 30. It is the common equation. Then I have used given two situations. For the initial situation, used water amount in 100 degrees is 10. 100 minus final temperature theta, 40. For this situation, second situation, they have given used water mass is 20 grams. Then we have to substitute 20 grams to this phase. And we can obtain second equation. Then we have to divide both equations and simplify. Then we can obtain theta value is 47.5 degrees. Then answer is 2. 1 kilogram of water contains in a metal container of negligible heat capacity is heated with 1 kilowatt immersion heater. If the temperature rises from 25 degrees Celsius to 45 degrees Celsius in 100 seconds, what is the average rate of heat loss to the surrounding for the container during this time? Specific heat capacity of water is given as 4.2 into 10 to the power 3. It is 4200 usual value. Then we can get power of immersion heater. It is the given heat energy for the system per second. There are two methods of use this heat energy. First one is system is increasing its temperature. Then we can write it ms theta over T plus there is an energy loss. Energy loss rate is the problem. We have to find the E over T value. Now immersion hot heater power 1 kilowatt, it means 1000 watt. Water mass is given as 1 kilogram, specific heat capacity 4200. Temperature difference 25 to 45, it means 20. Time interval is 100 seconds. Plus, we have to find E over T. E over T means heat loss rate to the environment. Then we can simplify it. 1000 minus 420 into 840. 10 minus 0 minus 0, 0, 10 minus 4, 6, 9 minus 8, 1. 160 watt. It is the energy loss rate from the system. Then answer is 3. Figure shows the variation of temperature theta with time t of a certain amount of ice. Initially at minus 10 degrees. When heated at a constant rate, the ratio of specific heat capacity of ice divided by specific heat capacity of water is the rate of heat energy given for the ice. ms theta over ml ms theta over T1. I have considered 0 to T1 time period. Given graph. It should be, this one should be specific heat capacity of ice, then I will consider SI. There is the same heat supply rate, then we can equal it to heat energy obtained by water ms theta over time interval T2 to T3, then time taken to increase water T3 minus T2. There is the same mass, we can cancel out m, but theta is different. SI into, you can observe 0 to T1 time period, temperature is changing from minus 1 to minus 10 to 0. It means temperature difference 10 divided by T1 should be equal to SW into, for the water, T2 to T3 time period, temperature increasing 0 to 100, temperature difference 100, divided by T3 minus T2. Then we can cancel out 1, 0. We have to find the specific ratio between SI and SW. Then we can get it 10 T1 divided by T3 minus T2. Answer is 2. It also related with previous graph. The ratio specific latent heat of fusion of ice divided by specific latent heat of vaporization of water. When finding specific latent heat, we have to get the time interval corresponding to phase change. We can observe that fusion is for time interval T1 to T2, and vaporization is from T3 to T4. Then we can write M latent heat of fusion divided by time interval T3 minus T2. This one is the heat energy related to heat energy given rate related to fusion. It should be equal to M latent heat of vaporization divided by vaporization time period is T3 to T4. It means we can get time interval T4 minus T3. Then we can cancel out M and N. We can find the ratio between LS and LV. It should be T3 minus T2 divided by T4 minus T3. So time interval related to fusion is T2 minus T1. You have to obtain the time period related with temperature at 0 degrees. It is fusion. T2 minus T1 over T4 minus T3. Then answer is 3.